All righty, it is 7 o'clock. So welcome everybody. We're going to start tonight out with a forum talk about the Makers Group from our very own Dean, KK4DAS. So Dean, take it away.
Great to be here. Your Maker Group kicked off a project just 2 months ago, February 17th. And we have 20 of our members, including, 18 of our members and 2 guests from places beyond who've joined us, who may eventually become members. Most of us are local, but we have Tom in Arizona, we have Wes in Bakersfield, California, we have Steve in Glendale, California, and we have Ian up in New York. So we got about 15 or 16 of us local and 4 or 5 up in New York. And we set out on a very ambitious project, which is for us to create single sideband transceivers, QRP single sideband transceivers on the 40-meter band. And a lot of people build kits. A lot of people build, direct conversion receivers and small test oscillators to send CW transmitters, but it is a relatively rare breed of amateur experimenter that builds a transceiver scratch-built from scratch. So that's what we set out to do, is build a 40-meter single sideband transceiver. So beginning with the end in mind, we're going to kind of go through kind of what that project is, and then I'm going to kind of show you where we are in the movie, and I think you'll be pretty excited. So here's the antenna. Is the sound coming through?
I started to calm down.
It is. Yes.
And I take it down, get something better, and I just started to.
4AK calling.
4AK.
2000 SB 200 linear, about 400 watts, probably to in-fed inverted L. So Jerry, wonder what's going on in Kentucky. W Zulu 4 Delta Alpha Yankee, November 4 Alpha Kilo in Sunset, South Carolina.
All right, so there you go. That is the where we're headed. 40-meter single sideband transceiver. So just to give you a sense of kind of how this rig works, this is the rig I built last year, and that's the Whisper map. When I did this assessment of my contact log, I had made 471 mostly SSB phone contacts to 43 countries and 40 states, over 5,000 miles. You can see over 4,000 miles. So while it looks like, a pile of wires on a board, this is a serious transceiver that actually works. It operates and it works well. It sounds good, gets good signal reports on the air. 5 watts single sideband on most of these things. And then when I, Australia and South Africa, those are FT8 or Whisper. These are all Whisper on here, but I've had just terrific luck with it. So that's what we're doing. The whole idea, low cost homebrew transceiver project. It was designed by N6QW Pete Giuliano, and if you listen to the podcast Solder Smoke, the Solder Smoke podcast, Pete is one of the presenters of Solder Smoke, along with Bill Mira. Bill is a club member, and he spoke to us a few months ago about homebrew. Well, Pete is the other half of that, and Pete has personally designed and built over 50 transceivers in his ham career. He is an experimenter and a builder, and so the goal is a 5-watt 40-meter single sideband phone and digital transceiver. It's controlled by an Arduino microcontroller that has the clock. And that's part of why it's possible for us to build this as beginner builders is that Pete has very cleverly taken the hard parts off our hands. So we have a microcontroller that runs the oscillators that control the BFO and the local oscillator. And we use a commercial mixer. We don't have to build our own diode mixers. And we use a commercial filter for the IF. But the rest of it, we build ourselves. So it's a relatively low part count. And in terms of overall complexity of a rig like this, low complexity, there's only 10 active components, 10 transistors. It's a modular design, good results. But what I pointed out to the guys, and Leon and others will attest to this now, this is not a kit where all the decisions have already been made. Yeah, there's no step-by-step insert tab A into slot B. It doesn't do CW yet, at least. It's not a software-defined radio. And if you're expecting an ICOM 7300 with a waterfall display and digital signal processing and all those bells and whistles, you're in the wrong group, right? So, and then Pete's wisdom, as everybody is learning, is the radio does not build itself. There's actually work to do this. Here's what it looks like from a high-level overview. Starting with the antenna on the lower right. On the receive side, you skip through those couple of boxes and you go right up to the bandpass filter on the left there. You go to a mixer. This is a super heterodyne transceiver. So for everybody studied this in your technician and general class licenses, but basically we take the signal, we mix it to an intermediate frequency, and then we do amplification of the intermediate frequency. Then over on the right, we have a product detector, balance modulator, and it goes to an audio amplifier. So if you count up all the boxes, there's only 7 or 8 boards in this whole transceiver, and most of it is bidirectional. Transmit and receive are the same. And where we are in the movie is we have built, starting on the right-hand side, we built our audio amplifier. Up on the top in the middle, we've built our Arduino SI5351 controller, the module with the display and the color TFT or a color TFT or whatever. We built that. We're in the process of building the IF module, product detector, receive, and transmit mixer. And several of us have completed that. And I'm going to show you kind of what that looks like at this stage. And we're about to transition to start working on the transmit side. So most of us are pretty well through with the receiver and and some of us are already receiving a 40-meter sideband off the air, and it's working really, really well. So here's what it looks like. Here's what you saw in the demonstration. This is my build. This is a classic breadboard build where everything is exposed. It's on a piece of plywood, and everybody is building it kind of like this, but people are thinking about how they're going to put it in enclosures. So again, we start with on the lower right, the audio amplifier. Everybody has built that already, or virtually everybody in our group has built that. Then up in the middle here, you got the display and the control panel. Most everybody has built that. And then what everybody is working on right now is this big board in the middle, and that's the IF module and filter. And once that board is complete, you actually have a 40-meter receiver. It will receive, actually it's a broadband receiver. It will receive the whole HF, it'll receive the whole HF general coverage bands. And when we build that little module up at the right with the yellow trimmer caps and toroids, that's the bandpass filter, and that'll put it on 40 meters. So it's a pre-selector that eliminates all the frequencies. So that's kind of where we're at, and that's what kind of people are building. I'm not going to go through all of this because that is the kind of the project. Now I want to kind of show you some of the in-progress work from the guys here. What you're looking at here is our Maker share site. So all our files are going up here, and I've made this available read-only to anybody who wants to see it, and it's in the last couple of emails I sent out, and I'll send another note to the General Reflector tonight with a link to it. But you can get on and browse this even if you're not part of the Maker Group. So the presentation I just made is on there, and There's a document, this homebrew single sideband transceiver document here. This is a document that started with Pete, but Mike Magnotti's been updating it, and it takes you through the whole build, one module at a time, one board at a time. As we make refinements, Mike is putting them in here and making sure that they're up to date. So you've got things like that on there. Pete actually came and gave a presentation at our group. That's on there. That's also on our YouTube page. And then we've got a set of folders for things like test equipment and references and mods and upgrades, SPICE models, data sheets. But the heart of the work is under the modules folder. And in the modules folder, as we go through and build each module, you begin to see the work that people are doing. So I told you everybody's built the audio amplifier. So let's just take a look at what's in here. So there you go, W4CLK Tim. There's his audio amplifier in progress. There's another look at it. This was Lee did for us a transceiver audio output stage analysis. Let's see, we got a video here.
Here we are with Tim, K4CTC, and his excellent example of the audio module. There's tension in the air because this is the first time it's worked. Let's turn to the builder himself.
I want to thank Don Taylor for helping me because I would have no clue on how to test this or bring it to life.
Well, now it's time for the moment of truth. We've got 10 volts going in. We have our sound source. We've checked everything. We're hooked up to a speaker, and we just simply have to check it out now. So here's our volume control. My God, folks, we have amplification. Well done, Tim.
Thank you. Thank you.
So you can see we're sharing progress as we go. We're also sharing, challenges that we have. So you're seeing kind of various versions of people's builds. So we're using a style of construction called Manhattan style, and what you're seeing is all the parts are mounted on the surface of the board, and we use the actual board itself as the ground plane. So anywhere you see a solder to the board, that's ground plane, and then those little pads are your islands of connectivity. So they're all connected together. And this is our amplifier. It consists of a single transistor preamplifier and an LM386 audio amplifier. And so this just kind of gives you a sense of kind of what the guys were doing as they were building the first module that we worked on. That's my initial build. That's the first board I ever built in my life, and I built it a year ago. And I pointed out a bunch of things wrong with my construction, and like the pads are really small, the wires are too long. It has all kinds of issues for stray capacitance and things. But I had this in my rig for 3 or 4 months, and it amplifies audio. So this is my current version of my build. You can see if you compare this to this, I over the course of a year, I've gotten a little better in my building techniques. So that's kind of the first stage we started with is the audio amplifier, and then we went on to the controller, and that's really fun because that's where you begin to see what the front panel is going to look like. And so Leon used his 3D printer and made this really cool looking front panel. And you can see kind of the behind the scenes view of it. And there you can see, there's the audio amplifier, and on the left there in the middle is the actual microcontroller itself. That's the Arduino, that little microcontroller that runs the display and sets the frequencies. It has the clock module on it, all that kind of thing. There's a little bit of close-up of it. What you're seeing there is the Arduino is the thing with the LED, so that's the microcontroller. And the purple board on the right is our clock generator. That's an SI5351 phase lock loop clock generator, and we use that to generate our local oscillator and our beat frequency oscillator that drives the mixers. A little bit of, again, examples of construction technique. There's another front panel that you can see, Owens KX40Y, nice brushed aluminum front panel. There's a look at the output of the clock generator, so it puts out a nice square wave. Franco has decided to jump the shark and dispense with the tiny little LCD and go with a fancy programmable color display. Of course, we have for each of these, we have presentations that go through the details. That's my original control panel that I just did out of a piece of bent aluminum from Home Depot. This is just to give you an idea. Okay, that's what's involved in the sketch for building it. That kind of shows you what the pieces and components are. This is the back of my controller module. So you can see there's different styles of construction. So when I said the rig doesn't build itself, there's work you have to do. So along the way, you decide kind of which construction technique you want to use. So this is a different construction technique than we saw before. This is a breadboard that already has the traces on it. And I set it up so that I can actually plug in the connectors for the buttons and the modules and so on. So just to give you a sense of kind of what various folks are doing. This is very important. We test as we go. So build a little, test a little, build a little, test a little, very important. Because as we have learned, if you build it first and then apply power, you let the magic smoke out and then it doesn't work. And you want to keep the magic smoke inside. So more testing, more traces. Okay, you get the idea. There's a work in progress. So you can kind of see as we start to build it out. And so at this point, when they've had it built to this point, they have a front-end controller and an audio amplifier. So not a whole lot you can do with it other than just kind of make sure your frequencies are set, you know. But when you get a little further on and you have the IF module built, then you can begin to hear things. So we're gonna kind of switch off and go look at kind of what the current state of affairs is next. All right, so then there's a bunch of, again, notes, parts lists, you know, what to buy, where to get it, all that kind of stuff. And the group has been doing a really nice job of helping and sharing with each other as they go. So you get a sense of kind of where, oh, there's our construction crew. That's the simple single sideband construction crew hard at work. They put the diodes in the wrong place though, I think. So, all right, so that's the controller. So the next module that everybody's kind of been working on is the IF module. And we started looking at, you know, how do mixers work and are we seeing the right mixing products when you put two signals in. Again, we had another presentation on mixers and a presentation on the module. More notes on how to test. There's a trace of our IF filter. So that's a 9 megahertz filter, flat at the top, nice deep skirts. So it does a good job of putting you in the 9 megahertz intermediate frequency. More looks at the filters. So you can see the guys have been testing and sharing their test results with each other. There's another look at the filter with the nano VNA, so you can see the trace. The filter we bought from a vendor in the UK called Spectrum Communication, and he built them special for us, so they have 50 ohm input and output matching, so it makes it very easy for us. So these are the kind of documents we're sharing with each other. Here's the layout. Here's how you solder it up. Here's how you put the pads on the board. You know, these are all kind of what the crew is doing as they're working on this together. And so this gives you an idea. All right, if you want to know how does the transmit stage follow the yellow arrows, and you can see how the transmit signal flows through on the right. So coming in from the right, from the microphone, it goes through a mixer. It goes to this amplifier here, this 2N3906. It goes through a filtering stage. it goes through a post-filter amplifier, it goes through a mixer, and then it goes out to the bandpass filter and out. So this is the kind of stuff we've been sharing with each other as we go. And I want to find a couple of. All right, so that's what the IF module looks like, built up with the crystal. I think this is Mike KD4MM. I think this is yours, right?
I think that's Leon's.
Oh, that's Leon's. Okay, cool. Yeah, so you see how the guys are approaching it kind of step by step. So we're hearing music. I'm not sure whose video this is.
This is Franco when he was picking up the radio.
Oh, okay,
Yeah.
so Franco was picking up radio on his mixer. Let me find. I want to find.
Without antenna. That's
Yeah, without the antenna. All right, here we go. This is KD4MM's test of the IF module. All right, so this is just a test with the signal generator, right, Mike?
Yeah, the other live tests are up higher up.
Okay, so we tested with a signal generator to make sure that we were on frequency. So you just got a tone going in, and it's going through. So this indicates that the rig is working. Okay, so we got a tone going through here. So let's see, this one, live test. That's the one I want. IF mod live test. There's 4 of them. All right, well, we'll just pick one.
Maybe we'll have a short net here tonight. Anyway, you guys probably heard me say that it's 69 degrees here on the plateau. Looking at
So having successfully tested my IF module on a frequency generator, which I use the Tiny SA to do, I have hooked up my IF module to my 80 meter off center fed dipole and have been cruising around the bands and have found a lot of folks that I can pick up with this neat little receiver. And let's see what else we can find here. Maybe up this way.
finishing up with my next to the last class here, and my internet didn't fail this time, huh?
There we go. Let's tune down and see if we can pick up FT8, which should be... Let's get this in the upper sideband. Oh my gosh, yep. There you go. FT8 booming in.
So let's see, you have an FT8 test, right?
Yeah, you can see it down there. There's a screen. Go down.
This one, okay, got it.
So for grins, I decided I would see if I could decode FT8 off of my little receiver here. Got it tuned in, upper sideband, using my speaker to my computer microphone, and sure enough, it's not a pretty screen, but it's absolutely picking up and decoding FT8 signals. So just another feature of this wonderful little receiver that we're building. The other thing you'll notice is that I was operating on 20 meters. This thing is wide open until we put the bandpass filter in it.
All right. That is right. So it's a general coverage receiver. It gets put on a band when you put a bandpass filter and a low-pass filter on for transmit. Now, just to show you that it's not all roses and wine and happiness and delight, we are also sharing our tales of woe with each other.
Thank you for joining me in another edition of Don't Do What Don Did. Despite having many excellent examples of a design to follow, Don decides to go it on his own and rearranges the pads into this potentially elegant 4x3 grid layout. Here's the first completed example. Looks pretty cool. The second completed example also looks pretty cool. The problem is that when you debug it, it doesn't look at all like what we expect it to. So every time you have a problem, you end up thinking, what the heck? Because it doesn't look at all like what it should. Even if it is electrically equivalent to this, you end up rediscovering that every time you try to debug. So don't do what Don did. Don also thought it would be very clever to mount his relay in a push-pin socket. The problem there is it's way too fiddly, introduces a whole bunch of fault points, and doesn't add a lot of value. Oh, yes, that is a burn mark where Don tried to scorch a hole into his relay with his soldering iron. No reason to do that either. Here, Don has retreated to the suggested design of upside-down relay, which makes it very easy to follow the reference architecture. So certainly don't do what Don did there. Lastly, Don thought it would be very clever to mount his project in two separate boards so it fit within his cigar case. Very fiddly, introduces a whole host of problems and not much value added. So don't do what Don did there either. So in total, I recommend you build the way the design suggests. Thanks very much for joining this edition of Don't Do What Don Did.
And every one of us along the way has shared a tale of woe in one form or other. We have blown up nanos. We have sheared off mixers on our drill presses. We have, in trying to demonstrate the mixer, managed to fry both a mixer and a nano at the same time by putting the voltage in, by configuring my power supply wrong and having voltage along the wrong rails. So this is homebrew at its best. Everybody, I think, is having fun. As you can see, we're making progress on getting a radio. I've challenged the crew to have their rigs ready so that we can have a Vienna Wireless single sideband armada on the air at field day, and and at least we'll be able to kind of work each other around and get out and make some calls. So that's the update on the Maker Group. As you can see, we're having a lot of fun. Feel free to stop in. We meet every Wednesday night on Zoom. You don't have to build to join us and kind of watch progress. So there we are. So let me turn it back to this KK4DAS. I'll turn it back to the K3NHD.
All righty. Well, thank you, Dean. That was a great update. And I've not had any problems building my radio, but that would require me to actually build it. So, no problems if you don't actually do any work. So, but really good update. Glad to see all the pictures once again. So it's a fun project either way. So yeah, if you're so inclined, join us.